You'll find arc length and area of a sector. So if I draw a circle here, and I consider that that circle has a radius, and it has an angle, okay? We desire sometimes to find the length of the arc, which is referred to as S. Okay? And this is related to something in a circle. What do we call in a circle when we go all the way around? Circumference. You remember the equation for circumference? Has an R in it, has a pi. 2 pi r, yeah. So circumference is equal to 2 pi r. But the difference is we're not talking about the entire circumference, are we? We're talking about a fraction of it. What fraction of the circumference are we referring to? We're referring to theta over 360. So if you take 2 pi r multiplied by theta divided by 360, that's your arc length. But it turns out that when you're working with radians, you don't have to use that formula. And we're just going to show you a new one today. And it's actually quite simple. S is equal to, and I want you guys to watch me here. I'm going to actually rewrite some of this a little bit. I'm going to take a theta and move it out front. I'm going to multiply by 2 pi over 360 times r. So all I did is I just moved the theta forward. I moved the 2 pi there. The 360 is still on the bottom. The r is out front. Commutative property multiplication allows me to move things around. I just got to make sure something's in the denominator. It stays in the denominator. Who can tell me what is 2 over 360? 180 in the bottom, right? And if we have that, then S is equal to theta times pi over 180 times r. And do you remember, how do we convert from degrees to radians? We multiply by pi, and we divide by 180. Like, this is actually the conversion from degrees into radians, isn't it? So it turns out that our formula is S equals r times theta when you are working in radians, because this provides the conversion exactly to radians. So all we got to do is take the radius and multiply it by theta, and that's it. Suppose that we have a sector and we're trying to find the area. So this would be a sector. I mean, it's a pie-shaped portion of the circle, and we call the area K. And so K is equal to, and let's see, if we're talking about area of a circle, what formula do we use for area of a circle? Hint, it involves r and it involves pi.
Is it pi r squared?
Very good. Pi r squared. And we don't want all of that, we just want part of it. So what part do we want? We want theta divided by 360. I'm going to pull just a little trick here. I'm going to try to convert this into radians, and in order to do that, I'm going to write, again, pi. I'm going to write r squared. And instead of theta over 360, I'm going to write 1/2 times theta over 180. And you can see here how I did that. Just 360 is 2 times 180. And now if I just move the pi on over there, I have k is equal to 1/2 r squared times theta times pi over 180. I just move some of the pieces around, and again, I have this conversion right here. This is the conversion to go from degrees into radians. And so our formula is as follows. Area equals 1/2 r squared theta if you are working in radians. 1/2 r squared theta if you are working in radians. So I actually generated the formulas for you. That's actually the hardest part, which you won't have to do. You just get to use them. We're not going to do all this stuff. In fact, my notes are a little bit different than yours, aren't they? And so what we're going to do is we're going to do example 7, and we're going to do example 8, and then we're going to get straight to your homework. You might actually be able to get it done before the hour is over. It says find the length of an arc on a circle of radius 24 that subtends a central angle of 60 degrees. And what that means, and actually on your worksheet, I have them all drawn out for you. We have a circle with a radius of 24, and the central angle is 60 degrees. The central angle is 60 degrees. So when it says that you want to find the length of an arc that subtends, in this math book, they say it subtends means it stretches from one side to the other, looking for that arc length S. And so what you need to be able to do on your test is to recognize that you are looking for length of an arc. And so therefore I use the formula S is equal to R times theta. Everybody good with how I came up with the formula? Let's make use of it. S is equal to, the radius is 24. And now here's the catch. For theta, you don't plug in 60. In order to use this formula, you must be working in radians. So let's quick do the conversion. 60 is? Pi over 3. (24) times pi over 3 is going to be 8 pi. This is the exact value in terms of pi. Okay? Suppose that the question was, round your answer to the nearest hundredth or something of that nature. Then you would just take 8 times pi on your calculator. I'm going to do that real quick. I wonder what time of my life I spend updating and relocating passwords and signing in. It is significant. There we go. And so I have 8 times pi, and I get 25.13. So approximate is 25.13. You should be able to express both if you need to. Okay? So according to the directions, you should be able to express both. Do you agree that that formula is simpler than the 2 pi r times theta divided by 360? You all agree that that's a little bit easier? All you have to do is just say we're going to convert it to radians. That's it. If you look at the next one, I've actually changed the problem slightly for you. Does it say radius of 12? But it says angle of what?
45.
It says 45? Okay. All right, so 45 degrees. All right. So find the area of the sector of a circle with a radius of 12. I'm going to draw a circle. I've got a radius of 12. And the central angle is 45 degrees. That's the arc. We don't want the arc. We actually want the area. We want that whole area on the inside there. And so I need to recognize that area of the sector. I have K is equal to 1/2 r squared theta. 1/2 r squared theta. 1/2, I have 12 squared. And then theta. I don't plug in 45. What do I plug in instead of 45? Pi over 4. Now we just got to multiply this out. I got 12 squared is 144, and 144 times 1/2 is 72. And so now I got to multiply 72 times pi over 4. 72 divided by 4 is 18. So 18 pi is the exact value. The approximate value, again, we would just have 18 times pi, and we get grand total of 56.55. So this is just kind of a short one-day lesson, just be able to find, again, as we said, area and arc length. If you look in your assignment, just to make sure we understand the directions, if you look at the very first one here, it says, so everything on the front side is arc length. So S is equal to R times theta. Everything on the front is arc length. And on the first part, it says that you can round to the nearest, 10. And then on the bottom there, it says do not round. So when it says do not round, it means to leave your answer in terms of pi. Do we understand? And then if you look on the back side, the problem changes to area. And so the area of the sector, again, is 1/2 r squared theta. That's the formula that you will use. Again, on the top, you can round nearest 10. And then on the bottom, you won't round. You'll write it in terms of pi. So if you're just getting practice using that formula, make sure that you are using radians each time and not degrees. Should go pretty quick. You guys got about 10 minutes. You might be able to get the whole thing done. I'll post the answer key.